Hello everyone, I'm Sarah, and today Tom, Lewis and I are going to talk through our final project for Command Shift, the Trade Journal. So why did we build this app? A lot of currencies traders typically use Excel spreadsheets to keep track of their trading. This app allows a more visual and user-friendly way to represent trade data, real-time access from anywhere, and negates the need for software packages such as Microsoft Excel. It is really easy to keep track of data with functionality to add, upload, edit and delete trade data. The app also includes a dashboard that provides useful news and market data, acting as a one-stop shop for any currency trader. As time and cost for this project were fixed, we used the Moscow method to scope our project, prioritising features into must, should and could have functionality. We then used Figma to wireframe our minimum viable product and Trello to break down, assign and keep track of individual tasks. We use GitHub for version control, creating branches for each new feature to stay organised and safe. We utilise Slack and daily stand-ups in a round to communicate progress and work through any challenges or barriers, and we did mob programming to collaborate on tougher tasks. Here is an overall view of our app structure. This shows how the data in our app is created, read, updated and deleted. Thank you. I will now hand over to Tom, who is going to go into further detail and show you our app in action.
Thanks, Sarah. So I'm just going to give you a brief demonstration of the app, starting here on our sign-in page, where a user is able to access their account by providing an email address and password. We've used Firebase authentication for this. Then on sign-in, you'll be taken to the dashboard page, and the idea here is that you can see live information about the market. So along the left-hand side, we've got tweets coming from a popular news desk. On the right here, we've got the CoinMarketCap API table. So this pulls the latest cryptocurrency price data and allows the user to reorganize it on page. So you can change a number of rows, and then you can also scroll through to see the data for different cryptos. Underneath that, we've got a news grid. So this pulls news data from a different API, and again, the user can filter based on what it is they want to see. So you can click finance, click business, and it'll change the information that's pulled through. We then have the add trade entry page. So this allows the user to individually add information about a particular trade. We've added a number of validations on this one as well to match what we've done on the back end with Sequelize, just to control the data that's going into the database. You also have the option to bulk upload data with a CSV. So you can click the button here, select your file, click upload, and you'll get a message when it's been successfully uploaded. Once the data has gone into the database, you can head over to the My Trades page, and this will summarize the data that you've added. So you can see here we can filter on different ones, filter on Bitcoin, bring up all the Bitcoin trades, filter on AUD, USD, you see the trades. You've also got the ability to edit or delete, so you can edit the information on page. If I change that to a lose, you can see there that that's swapped. Or if you decide you don't need that trade, you can delete it and it'll be removed from the saved trades. Finally as well, if you're not signed up, then we have the sign up page here, and with the first name, last name, email address and password, you can then create your own account, and again this uses Firebase. This slide shows the various technologies and packages that we use to build the back end. So firstly, we've used Node.js as the runtime environment, which allowed us to use Express.js as the back-end web application to manage the interactions with our Postgres database, which we containerize with Docker during development. We opted for a NoSQL database, and we used Sequelize as the ORM to achieve this. This then meant that we could create our data models with JavaScript. We used various other supporting packages, including Axios to manage our server-side API calls, NodeMon to automatically restart the backend app when making changes in development, and Multa and FastCSV to handle the CSV data being uploaded on the front end. So here in VS Code, I'm going to show you a couple of examples of the backend structure. Firstly, we've got the data models. We've got two tables, users and trades, both of which contain a number of Sequelize validations to control what data could be added to the database. We did this to ensure that we had a consistent data set which could then be analysed and filtered on a per user basis. We can then see here that there's a one-to-many relationship between the users table and trades, and that we've used the Firebase UID as the primary key to link the two. So this is a unique ID generated by Firebase authentication when a new user signs up. And when they do sign up, we're using Axios on the front end to send the ID to the back end and store it in the users table. We've also built controllers for each table, which allows to create, read, update and delete data as required. And the My Trades page at the front end makes use of these controllers for getting and updating the trades data. Our front end dashboard uses the CoinMarketCap API to retrieve the latest cryptocurrency price data, but restrictions on the service meant that making HTTP requests on the client side is prohibited. As a result, we had to route the calls through our own backend service, which you can see here. We've used Axios.create to generate a server-side API which can then be called from the front end. Finally, the functionality to upload a CSV of previous trade data to the database meant that we had to create our own controller and middleware to handle the request. Firstly, the middleware, which you can see here, uses Multa to handle the multi-part form data and then cache the uploaded file for later use. And the controller, which you can see here, pulls the file processed upload by the upload middleware, parses the data using FastCSV, and then adds it to the trades table of the database. So I'm now going to hand over to Lewis, who's going to talk you through the front end.
Thanks, Tom. I'm Lewis and I'll be going over our front end. We used React as well as various modules such as Firebase, Axios, MOE, and we used Render and Netlify for deployment of our backend and front end respectively. Further packages include React Helmet to render the external Twitter API script, FortAwesome for the embedding of icons, and React Router DOM for declarative routing, defining dynamic URL parameters, and managing history. One of the most pivotal areas of the front end is mytrades.js. This code defines a functional component called mytrades that manages trade data and provides editing functionality. Let's go through some of this code step by step. First, the component sets up several state variables using the useState hook. The location variable is obtained using the useLocation hook. The useEffect hook is used to fetch trade data when the component mounts or when the location changes. Inside the effect, we retrieve the authenticated user's UID using Firebase's getAuth.currentUser. If a user is available, the UID is stored in the Firebase UID state variable, and the getTrades function is called to fetch the trade history using the UID as a query parameter. The getTrades function makes an asynchronous HTTP GET request using Axios to a specific API endpoint. The response data is then sorted based on the created app property in descending order. The sorted data is set to both trades and filtered trade state variables. Next, there is a check to see if there are any trades or if the trades array is empty. If there are no trades, the component returns null. The code itself defines several event handler functions. Handle edit click is called when the edit button for a specific trade is clicked and sets the editing trade ID state to the corresponding trade's ID. Handle field change is used to update the updated field state object when input fields are modified. Handle save update click is triggered when the save button is clicked for a trade. It checks if any fields are updated, calls the handle save update function to update the trade data, and resets relevant state variables. The handle save update function sends a patch request using Axios to update the trade data with the provided trade ID and updated data. If successful, it updates the trades and filtered trade state variables with the updated data. Overall, this code manages trade data, provides editing capabilities, and communicates with a backend API to update or delete trades. In terms of challenges, we were faced with a few. However, two which stood out were Firebase and linking the UID to our database, which we achieved through importing the necessary functions from the Firebase software development kit, initializing the Firebase app with the Firebase config, initializing the Firebase authentication service and exporting the UID from the author object, setting the Firebase UID with this UID while also calling a controller upon the component mounting or the location changing. The second challenge we faced was the API restrictions, which related to the front-end API integration. When we deployed the application, we noticed that the API was not rendering the data. To overcome this challenge, we made the decision to migrate the API-related code to the backend. This adjustment allowed us to ensure proper data rendering and maintain the functionality of our deployed application. If we had more time, we'd have liked to have refactored the code to make it more dry so there's less repeating throughout. We would like to make the style more dynamic for the use of Sass. We would like to integrate further testing of the app, and we would also like to add a page for functionality for analysis and visualization of the inputted data through graphs. So that's all from us. Thank you for listening. We would like to thank the CommandShift tutors for their ongoing help and support over the last 6 months. And if you would like to find us, our GitHub and LinkedIn usernames are on the screen now. Thank you.